All right, we're going to take a look at a quick proof of the sine law here. Your sine law states that when you got yourself a non-right angle triangle, we have this relationship here. The sine of angle A over length of A is equal to the sine of angle B over length of B is equal to the sine of angle C over the length of C. All right, so to prove the sine law here, first thing you want to do is go ahead and drop your altitude line down here from angle A. This will give us a 90-degree angle. And I'm going to go ahead and establish some relationships here. I'm going to let this be x, and I'll let this be a minus x. You can see here that we know the sum of the entire leg of that triangle is a. Adding these two legs up, these two breaks up here, it comes out to be a, which is it's supposed to be here. Now I'm going to go ahead and use some relationships I have here. I know in this case here, I know the sine of angle C is going to equal my opposite. I'll label that h. So the sine of angle C is h over my hypotenuse, which is b. So just take a look at our right angle triangle on the left-hand side. We can say sine of C is h over b. Take a look at the right-hand side here. I can find out what the sine of b is. Since this is the sine law, I'm not looking at cos or tan. So I know the sine of b is going to be opposite, which is h, over my hypotenuse this time, which is lowercase c. So sine of b is opposite over hypotenuse. So we end up getting here h is b sine c, and likewise h is c sine of b. Equating these two, I know these, therefore b sine c must equal c sine of b, in which case the sine of c over length of c is equal to the sine of angle b over length of b. So we have part of our sine law proven. I need to incorporate angle A into this, so we're going to go ahead and take a look at this triangle again. And if we look at this triangle again we had here A, B, and C. I'm going to go ahead and calculate altitude line B this time. So maybe it's right about here. And the same idea as we had last time, I'm going to label this as my H. This will be A. This will be C. And again, I can label this X, and then this would be B minus X. So setting up my ratios here, I'm going to take a look here at the sine of C, in which case I know the sine of angle C is going to equal my opposite, which is H, over my hypotenuse, which is A. Again, I'm observing the triangle sort of going this way. And then likewise, I also know the sine of A. Again, I'd be referencing this angle here is equal to my opposite, which is H, over my hypotenuse, which is C. So again, this implies that H is A sine C, and similarly, H is C sine of A. Doing the exact same thing as last time, I know that A sine C will equal C sine A. In other words, the sine of angle C over C is equal to the sine of angle A over A. And now we have sine of angle C over C is equal to the sine of angle A over A. And you can equate now all three of these. And you can see it follows along here. I know that the sine of A over length A is equal to the sine of C over length C. That's using this result, but I know that that is equal to the sine of B over length B. And then we have our sine law proven. Thank you.